So here we're given a power series, and this is centered at 0. And we're asked to find the interval of convergence. So first of all, let's figure out the radius of convergence. We're going to use the ratio test. So I need to compute the limit when n goes to infinity of the next term and be careful here because we have n squared, so the next term will be n plus 1 everything squared. In absolute value, so these terms are positive, the only thing that needs absolute value is the x. And then I should divide by this term, but since this is a fraction, then you know that this is the same as multiplying times the reciprocal. So I'm going to write it that way, times and again, the absolute value is only needed here where the variable is, because 3 to the n and n squared are positive already. Now we're going to cancel whatever we can, and we're going to combine similar terms. So 3 to the n and this 3 to the n cancel, leaving us with a 3. Then the same for x to the n and x to the n, leaving us with an x. And then we have n squared over n plus 1 squared. And we need to compute this limit. Now the limit is in n, so this 3 absolute value of x is constant. I can take it outside. And then to compute this limit, you could expand this, but if the powers were higher, that would be a little bit of a trouble. So what we can do is write everything under the same exponent. Like so, n over n plus 1 squared. And now divide everything by n inside this square. So divide n by n, you get 1. And divide this by n, you get 1. And here you get 1 plus n squared. And now we know that this term approaches 0. So this fraction approaches 1 squared, which is just 1. So this limit is 3 absolute value of x. So now what does the ratio test tell us? It tells us that if this limit is less than 1, then this series is convergent. So here I get a condition on x that allows me to determine the radius of convergence. I have the 3 absolute value of x has to be less than 1. So absolute value of x has to be less than 1/3. So 1/3 is the radius of convergence. And this inequality tells me that x is between negative 1/3 and 1/3, which is consistent with the fact that the series is centered at 0 and the radius is 1/3. Okay, now we just need to test the endpoints to see if they are included or not. I'm going to get rid of this. Endpoints. Let's look at x equals 1/3. And sometimes people get confused at this point, but always keep in mind what we're trying to do. We're trying to find for which values of x the series converges. So testing this endpoint means that I need to plug it back in here and see if the series that I obtain is convergent or not. Now in general, whenever you plug in an endpoint back, you're going to get something that simplifies. If it doesn't, you might have made a mistake. Let's see what happens in this case. I get 3 to the n and then times 1/3 to the n divided by n squared. And now something does simplify because 3 to the n and 1/3 to the n just simplify to 1. And I get back down to the series of 1 over n squared, which is a famous series. It's a p series with p equals 2, which is greater than 1, so this is convergent. Because it's a p series with p greater than 1. This means that 1/3 is going to be included. Now let's test the other endpoint. Okay, this is very similar, but we have to be careful because here I have a negative to the n, so I'm gonna separate that first. Okay, like this. Minus 1/3 to the n is the same as 1/3 to the n times negative 1 to the n. Now these two simplify and this doesn't. So we have this series, and now this is convergent. So you could either use the alternating series test, because this is an alternating series. You have negative 1 to the n times 1 over n squared, which is clearly decreasing and has limit 0. So this is convergent by the alternating series test. Or if you take the absolute value, you get back to the series of 1 over n squared, which is convergent. So that tells us that this series is absolutely convergent, which implies that it's also convergent. So you could give either of those two reasons, and the conclusion would be that this is convergent. So let's say alternating series test. Well, one of those two reasons. I'm not going to write it down, but you should. And then, so the interval of convergence includes both endpoints.